Hello and welcome to this lecture where we'll go into common table expressions. So this is in order for us to combine several queries and to modularize our code so that we can create more and more complex queries. So instead of putting everything into the main query body, we will divide it into modular parts that can be reused. So this is useful when we're constructing very more complex and we want to have more clean SQL code. So let's move on to the slides. So here, common table expressions in CTE, it's called, in SQL to modularize and reuse code for better readability. So purpose of using CTEs in your queries. So it will enhance readability. It will reuse, you can reuse intermediate results with it. It's easier to debug and develop more advanced queries. And you can separate complex logic into smaller steps. You can make more smaller steps that are responsible for one thing only. So single responsibility principle you could use. So we start with an example of without CTE. So the question is, calculate percentage of homes that cost more than 10 million. So here we do select count star divided by 500 times 100 as percentage over 10 million from main.hemnet data, where final price is larger than 10 million. Okay. So what's the problem with this? Well, we have 500 here. This is a hard-coded solution. And that is not very good. That's not very neat because what if we add more rows and then it's not valid anymore. If we have, for example, 600 rows, then we need to change this to 600. We would like to have some kind of variable, right? So hard coding loses flexibility. Okay, but we have seen subqueries. Can we do it with subqueries? Yes, here we have subqueries. Select count star times 100 divided by this subquery select count star from main.hemnet data. Yes, it works. This is the subquery. However, subquery makes the code harder to read. So yes, it's easier to read 500, but it's hard-coded. Here we have something that is based on the result of this query, but it makes it harder to read. And this is a quite simple example. What if we had more complex, we had more variables we needed? So should we do a lot of subqueries everywhere? Then then SQL starts to lose its readability and it starts to be difficult to see the query, what we're after. So now let's solve this using CTE. Okay, looks like this. It might look, the question is this more readable? Someone would ask. So what it depends on if you're used to CTE or not. If you're used to CTE, this is quite readable. So learn the structure of CTE. So here we have the CTE part. And here is the main query. And you can take all the intermediate parts from the CTE and use it in your main query. So look what happens here. We have total homes. This is an intermediate result set or a CTE block. This is also an intermediate result set or a CTE block. So here total homes is this select count star as total homes from main.hemnet data. And this here, expensive homes is similar, count star, but here we have this where clause as well. And here, now you just take the expensive homes divided by total homes times 100 as percentage over 10 million. Uses the columns from the CTE result sets. So if you just read the main query, it is really readable. Expensive homes divided by total homes. I totally understand that. So then the question is, where do expensive homes and total homes come from? Well, they come from expensive homes, total homes. So expensive homes are just the column, which we have used alias here, count star. So it means it's that number of rows, total number of rows. And here total homes, or this the expensive homes are just a number of expensive homes. That we could actually change the column name to be even better here for readability. And here total homes is total number of rows, right? And then you take from expensive homes, total homes. So you reference the intermediate result set or the CTE blocks. Just as basic as this. So this is select from both result sets in the CTE. So here we have separated the logic so that we can reuse intermediate result set similarly to variables, right? So we can here use these total homes and expensive homes. We use them here in our main query. It's easier to debug and build complex queries. So here's another example where we're joining tables and CTEs. So here we use the Sakila database. And here we do left join. So join is outside of CTE now. So look at here. We have the CTE part with statement, right? With, and we do a CTE here, where we pick out the customer ID and the sum of the amount, so the total payment. And we only have those highly paid customers, right? So total payment over 150. And this we give it the CTE block as customer payment. So then from this customer payment, we pick the corresponding columns, right? And we join it on the main customer so that we actually can get the customer name as well. So here cp.customer ID comes from this customer payment, and total payment comes from customer payment, which we have calculated here, right? This total payment. So you see that we have done some calculations here. We have customer ID and total payment, the aggregation. And then we have joined it outside the CTE block. We have joined it with customer. And then we do some ordering. So joins can be done. It can be done inside of CTEs and outside of CTEs. So you can pick here. And what you should pick is a question. So which to pick depends on which that gives best readability and reusability for your case. So it depends on the case. General guideline is to keep each CTE block modular and have a single responsibility. So you don't want a CTE block to be unreadable, right? So you want it to solve one question and it has a single responsibility, and then you have a name that is readable that describes what you want, so that you can reuse it later. So keep in mind readability and modular. Yes, thank you for watching this video and see you in the next one. Bye.